So thank you for joining us. Again, my name is Patrick O'Halloran. I'm a solutions architect at Warescape, and I'd like to welcome you to our webinar with Mike Ferguson, Streamline Your Data Engineering with Data Mesh and Automation. So today we're going to find out exactly what is data mesh and what benefits does it provide. I'd like to just jump into this right away and introduce Mike Ferguson, our speaker today. He's the CEO of Intelligent Business Strategies. 40 years of IT experience. I had some other things to say, but he asked me to cut it short and just introduce him as the grumpy data guy. Is that it?
That'll do. Thank you, Patrick.
Okay. Before we get started, I will point out that at the bottom of your screen, there's a Q&A button. If you want to ask any questions, feel free to type those in. I may answer them live by texting them. Otherwise, we'll keep them until the end of the webinar and answer them then. So feel free to use the Q&A button down at the bottom. With that, I will go ahead and turn this over to Mike.
Thank you, Patrick. So good morning, good afternoon, good evening, everyone, wherever you may be. Many thanks for taking time out of your schedule to come to this today. So I do want to talk to you about the whole idea of accelerating data engineering, because we hear time and again, many companies, many people saying they spend 80% of their time engineering data and 20% analyzing it. Well, we want to do something about that 80% and reduce it significantly. And so really this session is about that. Before I get going, if any of you are not too sure who I am, over 40 years in the industry now, I started out as a regular DBA and very early in my career got to co-found a company with these two gentlemen, Dr. Edgar F. Codd on the left, who of course won the Turing Award for creating the relational model that caused the birth of relational databases. It caused the birth of the SQL language and data normalization as a design technique. Also, Chris Date, who, if you did computer science at university, you may have gotten his book, Introduction to Database by C.J. Date, which was widely read around the world. And myself, and then I went on, I was there with them for 4 years, went on to become chief architect at Teradata at the end of the 80s, the beginning of the 90s. And then I moved back to UK, where I'm based right now, started my boutique industry analyst firm and consulting firm on data management and analytics. Okay, you may also know, if you've been to Europe, the biggest data and analytics conference in the whole of Europe is Big Data London. I chair that. It's a 20,000 delegates event, over 180 vendors on the show floor, and over 300 speakers across 15 theaters. So it's a pretty big event. If you ever get the chance to be in London for that in September, be great to see you there. Okay, and just a little bit more about my company. All right, so let's talk about what we want to look at here. One is traditional data engineering and the issues that are currently happening within that today. And in a way, when we look at that, we'll see why and understand why, if you like, data mesh emerged with the whole idea of creating data products. And so I want to look at what those are, and then also say, well, how can creating data products shorten the time to engineer data to support multiple analytical workloads? And then, how do you go about designing those data products and have them linked so that we can kind of assemble them to kind of fit your requirements for your analytical purposes? You kind of rapidly consume them and build new insights. And then also how does data warehouse automation accelerate that even further? So let's get started. So first of all, let's just look at the kind of traditional things going on and what the issues are today. For most organizations that I work with, and I've been consulting all over the world for a lot of years now, and in fact was doing that over the last few days in mainland Europe. What I see is a number of analytical systems. which are typically aimed at certain kind of analytical workloads. That could be your classic data warehouse. I have clients with actually multiple data warehouses. It could be data lakes like cloud storage, for example, being used for data science, or it could also be Hadoop, which still is out there, by the way. Plenty of Hadoop clusters still out there, people using for data science and for collecting vast amounts of data on. I have a client at the moment doing, collecting vast amounts of IoT data on Hadoop clusters in various manufacturing plants that they have around the world. And so streaming analytics is another area as well. And of course, master data on the right-hand side here also feeds analytical systems as well as transactional systems. And all of this today is going on within most of my clients. And not only on premises, but on the cloud. In fact, pretty well all of it is available on the cloud these days. And for most organizations, probably got a hybrid setup, with some of this going on premises, some of it going on the cloud in order to try and produce the insights that are necessary for your organization. And executive expectations over the last few years are becoming huge around data and AI, particularly since the kind of emergence of generative AI, just over a year ago now, probably about a year and a half ago. And there's no doubt that people are getting measurable results from that, but they're not going to get maximum return on investment unless you've got a really high quality, solid data foundation, highly governed, high quality data, because you can't build and get good insights or even accurate predictions or generated content that is, free of hallucinations if you don't have consistent high quality data to build on. The trouble for most organizations is, however, is that they don't have a high quality data foundation. They've got silos, as we already said. There are different siloed analytical systems and aimed at different kinds of analytical use case. And each of these silos is taking data from various sources and using some form of data integration to clean and integrate that data, perhaps to populate a data lake for data science, or to populate a data warehouse or data mart, or to populate a graph database if you're using it for something like fraud analysis, for example. And the other problem is that it's very often the case the tooling being used to do that within one silo is not the same as the tooling being used in another silo. So, for example, people in data warehousing perhaps using ELT tools to clean and integrate data, whereas in data science they might be using Python. In a graph database they might be using something else. In streaming analytics they might be using something else. And so they can't see across the silos because you can't share metadata these days. There is no industry standard for doing that at all. And unless there is pre-built integration between tools, which is, depending on what tools you have, it's highly unlikely that people working in one silo are aware of what others are doing in other silos in terms of cleaning and integrating data. And so what you've actually got is this. You've got point-to-point development of pipelines. By point-to-point, I mean we are taking data from specific number of data sources, cleaning and integrating that data for a single purpose, for a single machine learning model to provide features for that, or for a graph database, or for a specific data mart, or for a specific data warehouse. And so it does make you think, well, how many times is the same data being extracted and transformed again and again for different analytical use cases, and how much money and time is going into that? And with more and more data coming on board, it's not just traditional master data and transaction data that we've been using in classic data warehousing for decades. We're now looking at machine generated data, such as IoT data, whether that's industrial IoT coming off equipment in manufacturing lines, or whether it's consumer IoT coming off of consumer devices on your wrist or in your pocket or wherever. That's all additional data. We've also got clickstream being captured as people browse your websites and traverse different pages on your websites, and various other infrastructure log files. We've got human generated data coming off of social networks, coming off of inbound email and web chat, going on with your customer service representatives, for example, or even chatbots. All of that going on, and photographs, videos, dash cams coming in, videos coming into insurance companies on a claims process. We've got all of this going on, plus all of the external data that you're buying in to complement what you already have and what you already know from your own data sources. So with all of this going on, the demand, it gets even greater. We have even more data sources on the left-hand side, and as more and more of those appear and grow, whether they're new internal sources or new external sources, then the folks on the right, who want to analyze it, the demand grows. So more and more people want that data. And so if you've got, a finite number of data engineers in the middle, they just become a bottleneck, which is what's happened to IT, generally speaking. Can't keep pace with demand. It's not their fault. It's not that they're not skilled. It's just there's so much going on. There's so much data that they can't keep pace with demand. And it's coming in everywhere. It's ingested into multiple places, whether that's coming into cloud storage, it could be coming into Hadoop clusters, SQL databases, or staging areas of data warehouses, whether they're on the cloud or on premises. But where we are for most of my clients, at least today, is we've got a distributed data estate with data increasingly spreading out across multiple data stores that are on premises in multiple clouds, in software as a service applications. We got data coming in off the edge, whether streaming data, for example, that we already talked about from IoT devices. And so just knowing where your data is becoming a challenge. And if you can't find your data, it becomes even harder to try and integrate it and know which is the best data source to get the data from. And if you look at what's happened over the last decade or more with respect to data science and with respect to kind of classic business intelligence, it's pretty normal these days to look around most organizations and see multiple BI tools. Also pretty normal to see a number of different data science technologies, different data science workbenches, Jupyter notebooks, Zeppelin notebooks, all of these being used, and a variety of different tools being used. And pretty well all of these now come with self-service data preparation capability. So whether you're a data scientist, you need to prepare data for your machine learning models that you're developing, or whether you're a business analyst and you need to get data from multiple data warehouses or multiple marts to produce your reports and whatnot, you're integrating data using self-service data prep tools. Now, we've learned from this, this self-service data preparation concept emerged about 11 years ago when we saw the birth of the likes of Trifacta and Paxata. Trifacta these days owned by Alteryx, and Paxata by Data Robot. But just handing out self-service data prep tools from different suppliers around the enterprise and say, you figure it out, has not turned out to be that good for most organizations. It's turned out to be chaos, more like this, people getting tools and going, well, I'm not too sure where the data is. And it's kind of a bit Wild West as people grab data, integrating it with a range of different tools and no ability to share metadata. And so potentially we get beyond the silo that we saw before, and everybody's building their own silo with inconsistencies inadvertently appearing because people take the same data and integrate it in a different way and transform it in a different way to somebody else. And I've used this quote a lot over recent times, but I love it. It's a quote from one of my clients who, when we did a review for them, said, everyone's blindly integrating data with no attempt to share what they create. And with data complexity getting worse, it's taking longer and longer to get this job done. But if you look at what most organizations have been doing to date with respect to producing data, it's been more like the picture on the left, when what they really want is the picture on the right. And trying to find data, even if it's already been invented in another tool by somebody else around the enterprise, if you've got the picture on the left, somewhere in there might be the data you're looking for that's already been produced by somebody else, but you don't know where it is and you can't find it because you can't look across tools, and therefore you think, oh well, forget it, I'll do it again. So with all of that going on, if you like setting the scene, you kind of think it's not surprising that data mesh emerged. And we saw the emergence of something called data products as a way to say, is there another way to deal with this problem? Of course, this was defined by Jean-Marc Degani, a picture you can see over here, who was at ThoughtWorks, is now CEO of a startup called NextData. Who defined the whole concept around data mesh, 4 different principles, as you see here. That paper, I think, emerged around 2019. And it was really about 2022 before we really saw the hype around this really pick up, and companies getting very serious about implementing data mesh and starting to get moving with it. And the idea behind this is clear the bottleneck that we saw earlier. Let's democratize data engineering and get multiple domain-oriented teams around the enterprise building pipelines to produce data products. And if you like, the collection, if you like, of data products that are being produced is being referred to as a data mesh. But the idea is that overcome the bottleneck in data engineering with a decentralized approach to doing this. And so, you've got within different domains around your business, you've got teams that are building pipelines, taking data from sources that they intimately understand in order to produce data products, which are self-describing and can be accessible through an interface and can be shared around the enterprise. But then you can kind of say, well, why did data mesh emerge? Well, we need as we said earlier, a high quality governed data foundation. And we didn't have that, right? We had silos. But we didn't want to wait for some monolithic foundation of data to be built. We wanted to do this incrementally. So we saw that we needed data products to kind of do that. Let's kind of get these, gradually build out this data foundation on top of a distributed data estate, effectively, to produce the high quality data that we need to share and reuse around the enterprise, given that there are more and more people around the enterprise that want access to that data. And if you could give it to them ready-made, that is to say, already cleaned, already integrated, and compliant and ready to go, it would save them a heck of a lot of time than if they have to go back to the raw data across a distributed data estate that you have here and struggle with all the different data stores and pick out the data that they need. So in a way, data mesh has looked at the whole problem and said, can we break this down into manageable pieces, much like we saw with software development? The whole idea is, could we rather than build these data stores for a single purpose, could we not build these data building blocks, these data products, and get multiple teams doing this around the enterprise, building different data products, which together would form a high quality data foundation that we could use for multiple analytical workloads. Now, there's a huge amount of writing about data products out there. And I think there's some very loose definitions of what these things are versus some more tighter definitions, if you like, of this. I do not regard something like a BI report or a machine learning model as a data product. I regard those as analytical products. What I regard as a data product is a physical, cleaned, integrated data set representing a business entity within the enterprise, like customers or orders or payments. It could be a virtual data product, that is to say, it looks like it's consolidated in one place, tastes like that, smells like that, but actually the data that is, the data is not necessarily consolidated, but to any user of that, it looks like it is. And of course, that could be provided through data virtualization. Equally, it could be that the pipeline's been built that produces the data product. And in order to get that data product, you can invoke the pipeline through an API in order to connect to the data sources, clean and integrate the data, and produce the data product on demand. But if you accept the differential between data products and analytical products, the one thing I would say is this: that there has to be foundational data products. By foundational data products, we mean there are critical data entities within every business. Customers, products, orders, shipments, returns, if suppliers, purchases. All of these things that go on, depending on your verdict, the industry your organization is in. If you're in insurance, claims, premium payments. These are foundational data products, and every company has them. And yes, you can build other aggregated and filtered data products on top of that, but you need these foundational ones in place. Otherwise, people will reinvent them again and again. And one way to do this that a lot of people are now doing because it's working well in business, because it is to create a data concept model, work with a business to describe the data concepts used in your business, and then for every one of those, we can turn those into data products. Another thing you could do, even just as a sort of quick start mechanism, is just make a list or an inventory, if you like, of the master data entities within your business and the transaction types within your business. Every single one of those could be turned into a data product with a unique identifier, an enterprise-wide identifier. But if you go talk to people in business within an insurance company about quotes and about premium payments and claims and renewals and brokers and employees and claims assessors and things like that, is everyday business discussions, everyday business terminology. These data entities are there within every business, and we should know what they are, because every one of them can be turned into what I call a foundational data product and documented within a glossary. So every data product that's produced in a data mesh needs to be documented in a glossary, which these days is typically held within a data catalog. So how does creating data products shorten the time to engineer data for multiple analytical workloads? Well, first of all, let's go back to our distributed data estate. What you can see here is that I could potentially, with a common platform, connect to all of these disparate data sources across my distributed multi-cloud data estate. Catalog would help me understand what's out there, and then have multiple teams use that common platform to produce data products, which can then be consumed by multiple different analytical workloads. In other words, build them once, reuse them everywhere. And we can coordinate the development of those data products by having a kind of program office in a federated organizational setup to make sure everybody knows who's building what and for what business purpose. And so that you can see here, it's not point to point anymore. What we've got is that we're building pipelines to create data products and then publishing those in a marketplace for consumption and use by multiple different kinds of analytical workloads. Go build it once, reuse it everywhere. And as we see the emergence of open table formats, which was the topic of my last webinar with Wordscape, we begin to see the ability to create data products and hold them in open table formats, which then exposes them to multiple analytical engines and therefore allows the same data to potentially be used by multiple engines rather than copied. If you're unfamiliar with open table formats, I'll get to that in a second. But the whole idea behind data mesh is this: it's ready-made, reusable data products, which are building blocks, each with their own enterprise-wide identifier that is available for you to kind of in a canteen style, in a sense. You should be able to go and find ready-made and pick what you need for your analytical use case. That does not necessarily mean everybody gets a copy, by the way, of these data products. It just means you have access to them. But clearly, think of the amount of time and effort it would save a consumer if they didn't have to go and build, engineer the data. If it's ready made, if they could find it ready made in a data marketplace, then they can then get on and deliver new insights, whatever that is, new predictive models, new recommendation service, new BI reports, maybe even a new data product, which can be themselves then published back into the marketplace for others to use. And so as you go along, you get progressively faster, right? As more and more data products go into the marketplace, perhaps 70% or 75% or 80% of what you need you'll find already made. And so you don't have to go and produce it again. And so the idea here is that over time, you're able to catalog your data estate and understand what's out there, produce a data set and publish that, then have people, combine these, integrate them, and create an integrated data product. And then from there, those data products can then be consumed by others who don't even have to go and engineer it anymore because they've already found it ready-made. They can get on and build their machine learning models and publish that to a marketplace. And then others can even find those and don't even have to go and build these machine learning models because they're already there and go use them. And so over time, this gets just progressively faster because more and more people come into this and they're further up this workflow. I mean, they're further up the pipeline. I mean, they don't need to go back to square one every time to go and re-engineer data from scratch because what they find is ready made. So that's accelerating everything. It's got multiple teams doing this rather than a bottleneck and a big backlog going on. We've got the ability to publish and get reusable data products so that we can share and prevent reinvention. And of course, from a designing perspective, we can, the way in which you can do this is to, for example, take your data concept model that I mentioned earlier. Every concept within a concept model can become a data product. So you can document those within the business glossary within your catalog. Once we have that gives us the bones, if you like, the skeleton, if you like, of these data products, a customer or a product or orders. But we need to get subject matter experts who understand that customer data, those product data, those order data to kind of connect, if you like, and complete the business glossary to give me all the attributes that describe a customer or describe an order or describe product. And we want enterprise-wide identifiers here, but the whole point is that we can get virtual communities of subject matter experts around the business who are intimately familiar with that kind of data to complete the definition of what one of the terms used to describe these data products. Once we've got that, then of course, you can then use those business data names for those data products in a modeling tool of, to create a schema for the data product. Now, I'm not going to get into what that could be. I mean, there's a number of ways in which you can look at data modeling techniques for this, but I don't have time on this webinar. I have addressed it on a previous Wirescape webinar, nevertheless. But then having done that, having got my schema and my common definitions to describe a data product, the catalog is going to help you identify the data, that you need to find out there across your distributed estate in order to allow you to go and connect to those sources and then get that data and build the data products, right? And so the whole idea is that I'm looking across my distributed data estate and I can work out what combination of data out there is going to be needed to produce a customer data product. So the whole idea is this is where metadata and catalogs come in, because we can sort of scan and discover what data is out there across our distributed data estate, but not just populate a catalog with all the physical data names. But if we can then map it to the glossary terms, we now know what subset of data across our distributed data estate is needed to create a customer, or is needed to create an order or a shipment, or whatever the data product is that you're trying to create. And then we can go ahead and build a pipeline that produces the data product that's described in the glossary. And do that for each one of the data products that you're trying to create, and have different teams around the enterprise building these individual pipelines, which can then be the data products created and published in the marketplace. And once you have that, if I pick up on what I spoke about in my last Wirescape webinar, which is the idea of storing those foundational data products in open table formats, you may remember examples of that being Apache Iceberg, Apache Hoodie, or Delta Lake. Of course, open table formats can be accessible by multiple engines, including a data warehouse database and other execution engines like Spark, like Presto, and others. And so it means that if the data is in open table format, you don't have to take a copy. I can create an iceberg table within a warehouse and point it at what's created in an underlying lakehouse environment. I don't have to copy it. It can be just accessible directly. Similarly, data scientists using a Jupyter Notebook and Spark can also access that data and use it to help provide data for their machine learning model that they're creating. And so what we can do is get shared data being used for multiple analytical purposes, and so the silos start to disappear. So then the question is, how does automation help with this? There's a couple of questions coming in, but if you forgive me, I'll wait to the end before I look at them. But the whole idea, by the way, of semantically linked data products, what we mean by that is, for example, if you take something like orders or sales in this case, could hold the foreign keys to customers, products, and channels. Like, well, which product? Here's a sale of a product which was purchased by a customer at a particular time through a particular channel. If those enterprise-wide identifiers are preserved within foundational data products, then in order to make use of some subset of these, you just pick the ones you want. Say, well, just assemble them. I just want to combine these ones to be able to allow me to do this analysis to produce this report. And so it's an assembly. You're getting ready-made data products in the marketplace, and you just assemble the ones you want to produce your insights, because you don't have to go and start again and engineer the data from scratch. And because the data can be stored in open table formats, we get multiple engines potentially able to access it. We don't have to give everybody a copy either. In addition, we then say, well, that's all great, Mike, and you can see how that accelerates the whole data engineering process and gets that 80% of our time, as we spoke about at the beginning of the session. We get that reduced significantly. But couldn't we go any further? remember, executives are pressing, come on, they want results, they want insights coming out of all of this data and AI. Couldn't we do more? The answer is, of course, you can do more. And as far as executives are concerned, the way I'd like you to think about this is think about Henry Ford when it came to cars. Right? Yeah, we could build custom cars. Everybody can go build their own car. That would be, really cool. It would take you quite a long time. But what happens if you could industrialize it? What happens if you could really create a production line to really start moving this at a much faster pace? We get multiple teams on the production line and you're able to move this thing along and build these data products and get them moving. Now, when it comes to industrializing things, you have to start standardizing. We don't let every team go off and build their own production line, and then once they've got the production line built, they can then build the products. We're trying to standardize on things and get things moving in a much more rapid pace. And this is where data automation comes in. The ability to accelerate the development of data products in this case. Of course, in the past, we've seen it being used to accelerate the development of a single system like a data warehouse. But as we move to a more modular development approach in data and analytics, then why can't we accelerate the development of those individual data products and allow not only multiple teams to be in place to clear the bottleneck, but if they could then use automation as well, that would allow lesser skilled individuals to take advantage of more highly sophisticated software to potentially automate this task and therefore get the job done quicker, despite the fact that they may have lesser skilled than a highly sought after professional data engineers who are being outstripped by demand around the organization. And that's really where where automation comes in, the idea that we can shorten this even further by doing far more of this task in a more automated way. And so rather than just having a platform where everybody goes and builds data products, what happens if we have the platform where multiple teams can use data automation to build data products and speed that up even more? And not only that, but if you wanted to create a pipeline that would combine these data products and allow you to, produce insights or provide the data needed for your machine learning model, we could potentially do that as well. And as I said, with open table formats being used to store data products, we don't have to have copies for everybody. We just give them access to shared data in open table formats, and they can do so from different engines. I can access an open table from Spark without going through a database engine. I equally, I can issue SQL to a database engine to access an open table. But the key point here is that open tables support ACID properties, which means that the integrity of the data is guaranteed. And therefore, you will get consistent data despite multiple engines being able to access and update data within open tables. But if automation could be used to generate the pipelines, that would be even more exciting, wouldn't it? If you have multiple teams around the enterprise, decentralized data engineering, but they're all using automation. Now we're really getting moving. Now we're really putting, foot to the metal here. We're really beginning to accelerate things because we've looked at the original problem where we had a bottleneck, centralized data engineers trying to build everything, more and more data appearing, many other analytical systems emerging as silos. But what we really wanted to do is somehow accelerate this. And yes, you can have multiple teams, but if you could get them all using common automation tools as well, so that the software accelerates the development as well as multiple teams using the software to help create these data building blocks, then we're in a position to, to really, um, tackle this problem of 80% of my time spent engineering data. And if I go back to this idea of describing data products in a catalog and the catalog knowing about the data that's out there and mapping it to the glossary, well, then surely the automation tool would then be able to tap into that, be able to describe the schema of the data product and then generate the pipeline to build the data product. And so we get into a world of pipeline generation and shorten the time to produce the data product dramatically. And with a divide and conquer approach of multiple um, teams building different data products to incrementally build this data foundation, plus the ability to have automation to speed it up as well. Now we really are beginning to motor to really get this job done at an accelerated pace that should, as more and more is created, then the folks on the right here, the consumers, they should get progressively faster, right? Because as we said earlier, 70, 80, 85, 90% of what they need's already made, already found it. It's already there. Don't need to go all the way back to raw data and do it again. So, and you could even look at it on the other side, on the consumption side, not just on the producing of the data product, but on the consumption of the data product, then using automation again in order to be able to say, well, I need to assemble these data products to be used as a star schema in my warehouse. Well, why can't the automation tool do that? That doesn't mean you have to copy the data. It might mean that the automation tool just creates a pipeline that goes and defines the tables and points them at iceberg open tables sitting um, with your data in it, and then you're immediately up and running. But the whole point is, it's rapid development, and you could maybe even look to automate some of that using exactly the same mechanism. And so, what we're getting here is a double win: ability to accelerate the production of data products and the ability to accelerate the consumption of them. And so I suppose then if I was to wrap it up, I've got some time for questions. I mean, I would say, most companies are dealing with a situation where they've got multiple analytical data stores these days, and they're still operating in silos. Whether that's multiple data warehouses, graph databases, data lakes, lake houses, whatever they are, streaming analytics on Kafka topics or whatever. We've got more and more data sources emerging, and data lakes are here. Several clients of mine have got multiple data lakes even. But what we want is agility. We need to be able to get rid of this backlog, and we need to be able to accelerate it without compromising the integrity of the data, without causing inconsistency. Because inconsistent data is not going to work when it comes to building trusted insights or getting machine learning models that give you rock solid predictions and recommendations, or getting large language models generating code or generating content without hallucination. We need consistent data to be able to do that. And so it's not just give people tools with a fast, or cars with a faster accelerator pedal. It's, can you put these things together in such a way that you can accelerate the ability to create high quality, secure, compliant data products that together can be linked together to give you what you need for different analytical workloads, and remove the idea that I've got to copy data everywhere all the time, and allow multiple teams around the enterprise who may be lesser skilled than the high quality, highly specialized, uh, perhaps IT professional data engineers, allow them to participate and upskill them and allow them to take advantage of automation software to be able to deliver these incremental data building blocks, which together form your data foundation and give you the ability to make data, build it once and make that data available to multiple analytical workloads. So I hope that gives you an idea of what I think is potentially possible here. And it's exciting because, every executive I know wants to shorten the time to value. But how do you do it in a world where the amount of data is getting more, greater volumes of it, greater number of data sources, and it's spreading out across a distributed landscape? There's a way through this. There's a way to solve this problem. And I hope this session's given you an idea of how that might be possible. And with that, I'll hand back to Patrick and see if we can take some questions.
Okay, thanks, Mike. Yeah, there were a couple of questions I answered while you were talking. Someone asked, do we get the presentation after the session is over? And yeah, you also mentioned a couple of previous webinars you've done with Warescape. So I just talked to our marketing team. I'm going to have them include links to those previous webinars as well.
Okay.
Because I've seen those and there's good information on those as well. Another question I answered was, would we have similar product lists for other domains when you're talking about product lists and you had your transactions and products? And you mentioned insurance, and I forget what the other one was. Banking, I believe.
Banking and insurance. Yeah, I just gave us two examples.
Yeah. So the question was, would we have similar product lists for other domains such as telco, retail, et cetera?
Absolutely. Yeah. I mean, of course. I mean, every industry's got these, and quite honestly, if you're a telco, you should know what your master data entities are and what your transaction types are. There should be a list of those within every business. Whether you're a telco, a retailer, an airline, a pharmaceutical, a manufacturer, insurance company, or a bank, or whatever. I mean, you should know what these are. I mean, it's not difficult to be able to make a list of those things as a quick start mechanism. I mean, it should be the case that we know what these are.
Definitely. And then some questions I've left unanswered. I'll just go through these.
Okay.
Is there value in Data Vault in the structure where you had the data products listed and the tools and things? I think it was slide 46, 56.
Okay.
Anyway, I happened to be at the Worldwide Data Vault Consortium last week that Dan Lindsted hosts every year.
Okay.
So I can talk about Data Vault all day long, but what's your opinion about
I think there is value in Data Vault. I mean, there's no question that Data Vault as a modeling technique, which is obviously as a data warehouse modeling technique, typically used on data warehouses, not so much on data marts, but on data warehouses. I mean, the beauty about Data Vault is it, in a way, takes a data entity and breaks it apart into hub, links, and satellites, right? I mean, so the reason why you might want to have a schema design, if you like, using Data Vault for a data product is change, right? Is to come up with a new version of a data product. Let's say you've created a data product, but now 3-4 months later, you think there's actually more data that could be added to this, which would give it an even richer, make it an even richer data product. You could potentially do that without having a massive impact. Um, I think, however, as far as the consumer is concerned, you know, if a data product is available and held, you know, with a data vault kind of design for the data product, then consumer doesn't need to know about that and shouldn't know
Yeah,
about it. They don't want to have to
there.
navigate that. They just want to be able to consume the data within it. The fact that it could be stored that way should be transparent to the user. But without a doubt, yes, I mean, it could be an attractive thing to do to allow you to create version control around data products and be able to introduce new versions with changes made to them very quickly and easily.
Yeah, the only thing I would add is while Data Vault is great for a data foundation, historical data changes, things like that, you always need some sort of presentation layer on top of it.
That's exactly what I'm saying. Yeah, I mean, to the
Yeah.
consumer shouldn't know that, right? I mean, consumer doesn't want to see that. What the consumer needs to know is the presentation layer, right? As you said, exactly that.
All right. The next question: data products are always stored in Lakehouse. Why data warehouse is separated from Lakehouse? Is this logical or physical?
So, if you've been monitoring or even look at my previous Escape webinar, I think the last one I did, you will notice that over the last 2 years, data warehouse database management system vendors have all been announcing support for open table formats. It doesn't every one of them pretty well has now got support for one of those open table formats, whether probably I would say that Delta Lake or Iceberg are the two most popular ones. I go to Snowflake, for example. It's probably nearly 2 years, probably about August or something like that, 2022. They announced support for Iceberg. You know, and several other vendors have done this as well. Microsoft, Teradata, you know, many vendors, Google, AWS, all of them. So data warehouses can have either proprietary table formats or open table formats, or a combination of both, I suppose. So when we say a data warehouse, you might say, is a lake house a replacement for a warehouse? Not necessarily. What you could do is you see them merging or morphing, if you like, together, because all of the data warehouse database management systems today are already supporting open table formats, and so therefore could directly access the open table without the need to copy it into a proprietary one from within the warehouse. And you could even go further than that. I mean, if you take what Google announced recently with Spark stored procedures in the warehouse. I mean, you can even run machine learning models as stored procedures in a warehouse, accessing open tables, all from within the warehouse. So the idea that you have to copy data between a lakehouse and a warehouse is not true. A data warehouse database management system today can directly access open tables in a lakehouse. So I think you should think more about the fact that data warehouses and lakehouses are morphing as opposed to one being a replacement for the other.
All right. The next question. This is a new term, data ocean. I'm not familiar with. Is the data lakes in the diagram? Uh, is the data lakes in the diagram the data ocean? First of all, I haven't heard the
Ocean.
term data ocean.
Me neither.
Okay.
So,
Clay, if you want to ask that question in a different way, that might help.
well, the only thing I would say, perhaps while Clay might be asking it differently, is that it's definitely the case today that with domain-oriented development of data products, that you could potentially give each domain their own lake. Now, that doesn't mean um, their own physical data store separate from everybody else's. I mean, it's quite possible to have uh, multiple lakes being created on on the same cloud storage, with different storage accounts. Similarly, you can say the same of lake houses. I can have multiple lake houses, but they're all using the same cloud storage. And so um, I, if you mean, could you have that and the combination of these domain-oriented lakes is an ocean? I don't know what an ocean is, but if that's what you mean, I don't know if my answers what you're asking, but I hope it does.
Okay, I asked him if he needs to. He can just
Okay.
rephrase that question. We got time for one more question. There's a couple of questions I haven't gotten to. We'll be sure and answer those and email you directly. But the one last question I would like to ask is, what are the key measures that organizations can take into account if they're new with data mesh? How do you get started with data mesh?
Okay, so the biggest roadblock to data mesh, as far as I'm concerned, is nothing to do with technology, nothing to do with methodology. It's to do with organization. You need a federated organizational setup. You need what I would call a program office. Typically, that happens to be a CDO program office. The job there is a coordinator. They are the coordinator of all of the things getting built. So if you like, they're the custodian of the Kanban chart that says, here's what we have to build, here's which team is building what. So organizationally, you need a federated organization. It's not just a case of having multiple teams, giving them tools and go, you figure it out. We've tried that before. This isn't a distributed organizational setup. We had centralized. You could go all the way up the other end of the spectrum and you get distributed. But in the middle, you get federated. And federated is, I have to have some overseeing organizational setup that sits above all of these teams and coordinates the development of it. Doesn't mean all the teams have to report into a single boss or anything like that. It just means that that program office needs to coordinate the development of multiple data products. So everybody knows who's building what, and that you can create a kind of nerve center, if you like, which becomes the focal point not only for the enterprise to know what's going on, who's building what, but also the teams, because they can then say, well, okay, here's the pieces that we're building, who's building the other pieces, and how does it fit together to solve this problem, helping our organization becoming data driven. So to me, I think organizationally, that's number one issue, I would have to say. The second thing I would say you really do need to do is you really need common definitions. You have to come up with the idea of, we need to describe our data products using common business terms, and therefore it has to be the business that decides upon these things. Now, there are some data products that are enterprise wide. I mean, customers, suppliers, typically, these things tend to be enterprise wide data. Whereas something like products might not be, because you have different lines of business with different kind of products, and so but nevertheless, I think we definitely need the idea that you have to have a common platform, that you have to have the ability to get your organizational setup right, and that you have to decide what data products are you building for what purpose. And that's really where you're talking about aligning with business strategy. So if you've got strategic objectives and saying, here's my, we're a bank, we're trying to reduce fraud by middle of 2025 by 15%. If that's a strategic objective and a target, then the next question is going to be, well, okay, what data products are we building in order to reduce fraud by 15% by middle of 2025? And who's building each of these data products? And then we can coordinate it so that we can, get this thing moving in a way that's directly aligned with business priorities and goals. Because the whole purpose is to build up a collection of these things, and then we can say, these are the data products, and then, by the way, these are the machine learning models and the recommendation engines and the BI reports and the generative AI software agents that we're building in order to reduce fraud by 15% by the middle of next year. So we're building a collection of these components which are going to contribute to helping the company achieve that goal. That's basically what we're trying to do here. But getting away from a monolithic development approach to a modular development approach with data and analytics.
Yeah, what I was thinking when you were talking about that was, although data mesh has a lot of technical components to it, it's not an IT project.
No, it isn't. It's a people project.
Yeah.
And if I do my own surveys in this area and my own research, and every time I ask it, what's the greatest inhibitor to doing this? Number one is organizational structure. They always come back and say that. The second other reason is that they can't get their data governance right, and therefore they're concerned that the data isn't going to be well governed, and therefore they don't think they can democratize responsibility to build the pipelines. I mean, I think you can do all of this. That there's a way around this problem as long as you can get your organizational setup, get it business aligned, and then you can coordinate the development, and if you have the right technologies to be able to do this.
All right, well, thank you, Mike.
Okay, all right, thanks.
We're a little past the top of the hour. I'd like to thank you and definitely
Okay.
all the attendees. As I said, you'll be getting a follow-up email from us with this recording. If you want to respond to that with any questions or comments you have, we'll be glad to continue this conversation. So, Mike, I enjoyed that very, very much. I appreciate your time.
Thank you.
Again, all the attendees, thank you, and enjoy the rest of your day.